So I'm going to assume you're at a point somewhat similar to the point I'm at here, where I have a AWS account set up. I also have a DynamoDB set up with a table that already exists. And I also have AWS profile set up. And I also have a DynamoDB client set up to point at that cloud instance of DynamoDB. So if you're not at that point, then this is probably not the tutorial for you, but there's probably lots of tutorials out there. So let's just check that this at least works. So I'm going to hopefully put in this song into this table here. So let's go go run main.go, and let's refresh. And yes, so we are writing to our table in the cloud. That's cool, but what if you actually want to run something locally, right? What if you actually want to run your table locally and on localhost and interact with that rather than interacting with the cloud all the time? The easiest way I've found to do that is via Docker. So you'll notice I just deleted a Docker compose file just then, but I'm going to recreate it again just to show you how it might look. Obviously, if you've already got a Docker compose file that has a list of services on it, then you can just add these services that I'm about to write to what you already have currently. But what we're going to do is we're going to actually use the official DynamoDB local distribution that's provided to us by Amazon. So I'm going to go DynamoDB. And you can see that Copilot is smart enough to autocomplete it. So let's just use that. What we're doing is we're pointing to the official distribution, which is here. We're mapping to port 8000, so that's our port through which we can interact with this running container. And we have volume set up here also to persist the data across stops and starts of this container. That's cool. That's actually gonna, if we run Docker Compose up now, that's actually gonna run a local DynamoDB instance for us at port 8000. But there's one more cool thing I just want to add, which is this DynamoDB admin. You can see that Copilot's smart enough to know about this as well, but this is a really good thing for you guys to know about because it provides a kind of a nice GUI that runs at port 8001. Well, you can actually configure that as you like, but it allows you to interact with your database, add items, view the items that you currently have, and so on. So let's do that. Let's tab and autocomplete that. Great. Now let's go Docker Compose up. And it should do its thing. And if we open up localhost 8000, great. So you see here we have a GUI running. And we can create a table. So let's call our table the same thing as the table we had running in the cloud, music. And let's add a primary key here, partition key rather, and let's call that artist. Okay. So here's our table. Now we want to actually point our DynamoDB client to this locally running table. So what's the best way to do that? Typically, you distinguish prod from dev using environment variables. So let's just mock one out here, and let's call it env DDB local URL, and let's call it localhost 8000 because that is what DynamoDB is running on currently. Now, what we want to do here is we want to actually see whether this environment variable, our fake environment variable, has actually been set. So let's go if env DDB local URL is not equal the empty string. Treat as dev point to locally running DDB. Else we will do what we did here. So let's start by moving this stuff into the prod case. So this worked before and it will continue to work so long as this equates to the empty string. But if it's not the empty string, if we do have a locally running DDB host that we want to point to, then we need to fill out this block here. So in order to point to a locally running DynamoDB instance as opposed to a cloud instance that's the default, we actually need to create a different AWS config. So let's do that here. Let's go config load default config, and let's also pass the context, same as what we were doing here in the production case. But the key difference is going to be in what's called a custom resolver. So when you do load default config, you can see this has a variadic options parameter here, which can accept an arbitrary number of load options. One of those options is called with endpoint resolver with options, and this actually accepts what's called an endpoint resolver. So you're going to go aws.endpoint resolver with options func. Now this accepts a function which takes as parameters a service, a region, and various options. But the key thing is it needs to return one of these endpoint structs. So let's do that. Let's return aws.endpoint with a URL, and that URL is going to be this non-null env-ddb local URL. Okay. And it also expects potentially an error. We're just going to return nil. Now, if there's an error, we panic. Good. And let's make sure that's set here. Cool. So if we run go run main.go, this block gets hit. It realizes that the env-ddb local URL is not the empty string. In fact, it points to our locally running DynamoDB instance that we set up via Docker. We enter into this block and we create a custom AWS config that has a custom endpoint resolver that points to our locally running DynamoDB instance. So a bit of a mouthful, but let's try running it. And let's refresh here. There we go. There's music. And there we have our artist, Taylor Swift, added to our locally running DDB. And if we want to go back to talking to the cloud-based DDB instance, we just set that back to the empty string.